She makes shame shims by the seashore. She makes shame shims by the seashore. Hello Internet, my name is Quinn and this is Blondihacks. It's maybe the final video on my big steam engine project today. We are going to do all the finishing touches on this engine. We're going to put it all together and we're going to see it run for real. It's going to be a lot of fun. Let's go. The time has come to paint this beast, so to do that I of course need to disassemble it. In order to make sure it all goes back together correctly, I'm punching any pieces where orientation matters, which being a homemade steam engine is all of them. I'm also doing my best not to touch anything that involves valve timing, because as you may recall, I accidentally got the valve setting perfect on this engine the first time I put it together. So I'm marking the position of the eccentric on the crankshaft, and if possible, I'm going to not touch the eccentric on the crankshaft so that the valve timing will remain right where it is. I also marked the valve stroke setting on the valve rod that goes into the eccentric strap there. Those are the only two things that should affect the valve timing. Quick sidebar here, a lot of people asked in the Glass Oilers episode, where does all the oil go? This is a total loss oil system, so like any steam engine, the answer is everywhere. Usually there's some sort of sump in the bottom. In this case, it's the crankshaft pit there that also acts as a sump to catch oil and water. And there you can see the contents of those oilers. I'm going to be addressing this here in a moment. For some reason, this main bearing was particularly ornery. I thought maybe there'd been some moisture that got under it and maybe it rusted into place. This hasn't come apart since before my big move, and lots of things did get moisture in them during that move. That might be what happened here. And no amount of prodding, poking, or tapping would loosen it. So in the end, I ended up using a machinist jack and a brass bar here to tap the base off of it thusly, and that finally broke it loose. And let's see what the damage is underneath here, why it's seized up. The answer is nothing at all. That's a mystery. Okay, well, so be it. In order to make sure I get the orientation of the two bearing caps correct, I'm going to punch a letter F on the back of the flywheel side bearing. The components of the main bearings are already punched to match, and the orientations of them are already punched, but I could easily accidentally swap the bearings from one side to the other if I'm not careful, so this little F here should prevent that. To prepare for paint, I'm degreasing everything with acetone, and this is also going to remove all of my latent Sharpie marks and layout fluid and so on that I didn't get around to removing previously. Now, any low spot on a steam engine is always going to end up acting as a sump, whether you want it to or not. In this case, the crankshaft pit definitely collects oil and water, as we've seen already. So I'm going to put a drain plug in the bottom of it for now. Eventually what I'm going to do is probably plumb this out to the front of the base where it can be put into a catch basin. But for now I'll just drill a hole in it so that it's easy to drain this, and I'll put a plug in that hole. The ultimate goal for any stationary steam engine is to be built into a steam plant. So at that point you've got all of the infrastructure that went around a real steam engine. And part of that infrastructure is drainage for management of oil and water waste. So in this case, this drain plug could be plumbed into the front of the base and then plumbed into some other part of the steam plant, such as an economizer or a condenser, things like that. But as I said, for now, I'm just going to put a plug in it. So I found this little mangy scrap of brass in the junk pile that's been waiting for its moment to shine. And that moment is here. So I'm just going to turn a quick little hex-shaped plug out of this. And Yahtzee. There's my little plug fresh off the Scotch-Brite wheel, and let's fish that down in there and see if it's going to work. This might leak a little bit, but some Loctite 545 will fix that if so. Here you can see how that's going to run straight through to the bottom, and then I can easily add a plumbing fitting there for later if I need to. On to the actual painting now. I'm going to start with an acid etch primer, which I like to do for bare cast iron like this. And I'm using the same stuff as I used on my previous engine. This is an automotive acid etch primer. Being automotive, it's very, very good. and smells very, very bad. You really, really need to wear a respirator with this stuff. And after doing this, my shop was uninhabitable for 24 hours. This stuff is really, really nasty. The paint is not so bad, but this primer, oof, lethal stuff. Really works well though. Here's a tip to avoid needing to mask off all the machined surfaces. Just orient your brush strokes such that they move towards the machined surface off the edge, like so, and then none of the paint will get on that edge. If you paint the other way, or if you paint along the edge, then the bristles will throw paint around the corner onto the other surface. The brush that you see me using for the primer are these really, really terrible ones that my local art store sells for 99 cents. They're completely garbage as paintbrushes, which is perfect for this primer because this primer destroys any brush that touches it. There is no solvent that will rescue this brush when you're done, so just treat them as disposable and then save the better brushes for the paint. Speaking of paint, the paint that I'm using is this Pour 15 engine enamel. It's the same stuff I used on my previous engine, and it's really, really good. It's engine block paint, and it's incredibly durable, handles every chemical that a steam engine encounters, and has no trouble with the heat of the steam engine. It goes on beautifully. It's meant to be sprayed, of course. It's an automotive paint, but it brushes on just fine. The only catch with this stuff is that it has a very long cure time, which I assume is related to its superpowers of heat and chemical resistance. It takes a full 7 days to cure, although I've found that it's cured to the touch to where you can handle the parts within a day or two. With everything painted and cured to where I can handle things, I can start assembling the engine now. I'm going to work my way up from the bottom, and I'm going to be adding hardware and such as needed. So to start with, I need to start replacing these Philister head screws that come with the kit with studs and nuts made from threaded rod and hex bar stock. I think studs and nuts just look better on a steam engine, so I think it's worth the time to make them. I'll see if I can get away with threading this stock through the spindle so I don't have to cut it. The risk here is that it'll flop around too much because it's thin stock, and sure enough, it's flopping in the breeze back there, so I'm going to have to cut it short. It's nice if you don't have to cut pieces off of stock because there's always some waste when you have to cut them, but so be it. I cut a shorter piece and away we go. I actually do have a cat's head for this lathe that I made to go on the back of the spindle and help support stock like that, but the headstock on this lathe is so short that it really doesn't help very much anyway. My method for making nuts is simple if inelegant. I simply face off the front, and then I drill and tap as deep as my tap wrench will allow me to go, which usually ends up being about 4 nuts for model scale stuff. And then I part off those 4 as a batch, chamfering with the file on each edge as I go, and then pull the stock out, continue drilling and tapping another batch, and so on. Anytime I make hardware like this, I always like to link to a video by Mr. Crispin who shows a really elegant way to do this involving a custom ground tool that does the parting and the chamfering all in one step. It's very, very nice, so I'll link to that below. For studs, I always rough cut them with the hacksaw first and then face the ends down to final dimension. If you try to part them off with a parting blade, the threads cause the blade to deflect and chaos ensues. It's madness. So yeah, again, this is not the fastest way to do it, but this is the way I've been doing it. It works fine. And a nice little chamfer on each stud makes the ends of it look really nice. Some of these fasteners would also benefit from washers to protect the paint, so I've got some stainless bar stock that I chucked up here, and I'll make some washers using the same method as I do for nuts, just, without the threading, because, I don't know, I guess you could thread your washers, but I don't know what kind of monster that would make you. I'm sure the Germans have a word for that. With this collection of hard-earned hardware, I can begin assembly, again starting from the bottom and working my way up. I'm really, really glad I punched and pinned everything on this assembly because it's going together very nicely now, and I won't have to spend hours getting this engine to run properly again, hopefully when I'm done. For the studs, I put a little Loctite on the bottom there and thread them in until the depth looks right. Aesthetically, I want the stud to stick up just a little bit above the nut there. So I'm just threading them in until it looks like that's going to be the case. And then I let the Loctite cure before installing the nuts. On to the main bearings next. They get the same procedure done to them for the Loctite. These guys didn't get washers because there wasn't really room. If you do get paint on the machined surfaces, as I managed to do here, one of these razor blade scraper dealies takes care of that in very short order. This tool was actually sent to me by a viewer recently. This is one of those tools that I didn't think I needed, and now that I have one, I don't know how I ever lived without it. I'm ready for the crankshaft now, and I'm very proud of myself. I managed to disassemble, paint, and reassemble this crankshaft without ever touching the eccentric, so the valve timing should remain intact here. I'll give it a little startup oil here, give it a good start in life. It seems to be spinning very nicely, so the main bearing's seated well. And now up to the crosshead. That slides right in there. Again, I punched those two parts there for orientation, and the wrist pin goes in there. Again, a little bit of oil on that. And now it's gasket time. Recognize this thing? This was the drilling template that I used through many operations on this engine, and I've been saving it for today because I'm also using it as a gasket template. So I got the inside and outside dimensions from that and also center punched the bolt hole locations. I cut that out with an X-Acto knife a little bit inside the line on the outside and outside the line on the inside to give some clearance around the edge of the gasket. And then I'm using a saddlery hole punch here to punch those bolt holes out. You may recall this bolt pattern is a weird one. It's not a simple radial pattern. The bolt holes only have two orientations where they line up, as you can see here. So I got one more important use out of this drilling template. Then the little chunk out of the center was perfect for making the gaskets for the valve heads. So moving up the stack now, the inboard head goes on with its gasket, and now I can mount the cylinder. I've pre-installed the lower studs there. Those have been Loctited in, of course, and the nuts go on there to secure the cylinder. Now time for the piston. It's time for the piston rings, in fact. I have not previously been running rings in this piston, but now is the time. The kit comes with these Teflon strips with which to make the rings. They're very tight fit in those grooves, so I'm just wrapping that around and then I'll cut them to length. You want a little bit of a gap, of course, on any kind of piston ring. I don't think it's so critical for Teflon rings. Any kind of steel ring, of course, you need a gap because they're going to expand as they heat up. But it's probably a good idea to have a gap even on rings like this. And then between the two rings, I orient the gaps 180 degrees apart. But again, on a model engine, probably not that critical to do that. These piston rings did require a little bit of fitment. The first one was close and only needed a little bit of massaging to go in, but the upper one, as you can see there, got stuck. So I tuned up both of these rings the same way. I put the entire piston assembly in the collet chuck in my lathe and just touched the Teflon with some emery a little bit to just shave a little bit off the top of it. Probably when I machined those piston ring grooves, I didn't machine them quite deep enough, or maybe the Teflon is a little bit thicker than it's supposed to be. Either way, it was an easy job to get those to fit. Now, once that piston rod is installed, it's time for piston rod packing. As you can see up here, there's a gap in there where you're supposed to stuff this Teflon cord in. Traditionally, this was graphited yarn, but nowadays we use the same Teflon cord that you use to stuff certain kinds of faucets with. It's pretty good stuff. It works fine. On this particular engine, it's quite difficult to stuff it up in there. I find a small diameter blunt punch works the best because you can get it up in there and it's not going to damage the cord. Then the packing nut goes in on top of that to compress it and seal that up. And just tighten the packing nut basically as tight as you can get it while still allowing the piston rod to move freely. And then once the engine is running, if it leaks, you tighten it up a little more. And if it still leaks, well, this being British engineering, you put a tray under it and call it character. Next, the jam nut for the crosshead goes on. And now I can thread the piston rod into the crosshead, which I find is easiest to do by just putting a socket wrench on the top of the piston. Now the trick here is that that jam nut has to clear the packing nut for the piston rod. And I actually had some difficulty with this. I could not get them all in a position such that the packing nut was in the right place and had clearance for the jam nut. So I ended up grinding the crosshead jam nut thinner on my bench grinder until it would just fit there. You can see how close that is there. It is not touching a top dead center, but boy, it's close. But hey, clearance is clearance, Clarence. Don't call me Shirley. Now the outboard cylinder head can go on, and we're very, very close to being able to run this engine. The last thing to go in is the valve train. So once again, a little assembly oil and everything, and I'll get the eccentric strap on there. I only minimally disassembled the valve train here just to make my life easier. There was no need to disassemble all this stuff for painting since none of it is painted. But right about here is where I noticed that, oh, I actually never made the packing nut for the gland on the lower valve head. With all the parts on this engine, it's easy to miss one, and sure enough, I missed one. Luckily, it's a very simple part. It's just some hex bar stock, which I seem to have lost. I know the kit included it, but knowing me, I made something else with it. So I had some similar stock in my junk pile, fortunately. It's just a simple round profile with a threaded hole in the middle of it. And this part is so nice that I made it twice. I tried to install it and thought, you know, there's no way for the packing to be secured. And that's because the big threaded hole wasn't supposed to go all the way through. It seems I'm a little bit rusty after the move on actually following a drawing. The valve gland is pure luxury to pack because I can do it on the bench. You can see how that just threads on there around that boss on the lower valve head there. That should seal nicely. And now this whole assembly can go back in the engine. Again, the only thing critical here is that threaded spacing at the bottom there where it threads into the eccentric strap. That double nut arrangement there sets the length of the valve stroke, and the drawings for this engine actually include quite an extensive procedure for setting the stroke of the valve. That's really crucial. You can't set the timing until the stroke is correct. I also noticed at this point that I never got around to cleaning up that valve rod after all of the heat bending and other processes that I did to it. So I guess now's the time. I don't want to dismantle the valve train, so I just used a Scotch-Brite wheel on the Dremel to clean it up in situ. Okay, everything is assembled, so let's get an airline on this thing and see if it runs. It ran beautifully when I took it apart, so hopefully it'll run once again. And the answer is sort of. It started running really well, but then after running for a while, it starts to lose steam, pardon the pun. You can see that it starts laboring and running slower even though the pressure is remaining constant. And in fact, if I run it long enough, it will actually lock up. So something in there is binding, but not immediately. You can see how it runs okay, but then it's gradually slowing down. If I leave the pressure at the same amount, then it'll eventually stop. And I can force it to run by turning up the pressure, but there's something not right here. I actually spent a number of hours debugging this. The process of debugging a mechanical system is very much like software. You have to eliminate variables, isolate subsystems, and test those systems. So in my case, I was able to isolate the binding to the top half of the engine. I knew it was somewhere in the piston, piston rod, piston gland nut, that kind of area. I tried removing the piston rods, I tried removing the gland nut, running it without various sections that might cause binding, and eventually narrowed it down to the interaction between the piston rod and the gland packing nut. First of all, my gland packing nut was a little bit too close fitting, so I opened it up 1/1000th with an oversized reamer, and that helped a lot. And the other thing that I found was that the finish on the piston rod was causing problems. I knew this piston rod was going to be trouble when I made it. You might recall back in that video, I kind of complained that the kit came with this piece of brass round bar that you were supposed to use as is as a piston rod, and I didn't like that very much, and this is really, I think, where it's causing problems. So I chucked it up in the lathe, and I took a bunch of emery paper to it, starting with 400, and then I went to 1,000, and then 2,000, and then 2,000 wet to put really a nice quality finish on this brass rod. I believe that the reason the engine was slowing down that way was because the piston rod was dragging in the valve gland packing nut because of the poor finish. And the gland packing nut was actually scoring lines in the piston rod and then accumulating brass shavings. When I took it apart, the gland nut was actually full of shavings, and that continued until the shavings packed into the nut and bound it all up. Now you can see the gland packing nut moves very, very well on that. So this helped a lot. That was 90% of the problem, and then I also opened up the interface between the piston and the rod a little bit, again with a 1/1000 oversized reamer, And I think that may have helped a little bit as well. Just give everything a little bit more room to compensate for any imperfections in the piston rod there. Really what I should have done is thrown that away and made a proper one out of some precision ground stainless, something like that. While I was working on the engine, I also noticed the crankshaft had an excessive amount of end float, which was also causing some binding, I think. I'm not quite sure how I ended up with this. I don't think I had it before, but I probably did and just didn't notice. So the gap there is 22 thou, and I figured the easiest thing to do is just make a little bronze shim to go in there and take that up. I'm going to do it here on the flywheel side because, again, that way I can install the shim without having to touch the eccentric and disrupt the relationship between the eccentric and the crankshaft. So I can just sneak the main bearing out here and I'll be able to slide this in. I found a really nice piece of 932 bearing bronze in the junk pile, and I'm going to turn a very thin 20 thou washer effectively out of this stuff. Machining a very thin part like this is not necessarily the best way to do it. You're probably better off stamping it out of sheet metal, but I only needed the one, so I got away with this. Now I can sneak the shim in there and reinstall the main bearing and crankshaft. I suppose a nicer way to do this might be to remake the main bearing on this side and make it 20 thou thicker. But then the main bearings on both sides would be different, so really you'd want to remake both main bearings and make them each 10 thou thicker. Nah, it's a lot of work, so shim it is. And that worked really well, no more end float. Well, after many hours of fiddling and tuning, I'm pleased to say the engine now runs very, very well. Let's just give a listen. Really nice and even, runs at very low pressure. It's happy right around 5 psi, and this is with all the rings and gaskets and everything in it, so this engine is tight like a steel drum right now, and it still cruises along at 5 psi. Really happy with that, honestly. Now, I'm thinking about ways to run this on live steam. I don't have a boiler big enough to do it, but I do have some ideas in the works, so stay tuned for that. Assuming I get that to work, there's going to be one more video in this series, because you got to run it on live steam or it's not a real steam engine. Well, this makes engine number 4 under my belt, and I think I can say this is probably the nicest one I've built. It was a lot of fun to work on a bigger engine like this. It was very challenging to do this engine on my machines, but I'm really pleased with how it came out. I hope you enjoyed watching me make this thing. If you missed any of the parts, there's of course a playlist like all of my major projects, so go check out my playlists for the whole series of building this engine. Maybe you want to binge it again from the start and just relive the whole process. Maybe you've got better things to do. I don't know. Anyway, thank you very much for watching. Thanks very much to my patrons who make all of this content possible and are feeding me and Sprocket, so she thanks you as well, and I'll see you next time.